Today we're going to discuss about the access control list. So the access control list. So in this topic, we're going to discuss about the access control list operations, how the filtering will work. So we'll explain how the filtering works. What are the wildcard masks? How do we create access control list? How do we place them? How do we configure standard one? How do we configure advanced one? How do we create a standard, a numbered one, named one? And we'll see all these topics. So what is an access control list? An access control list it's a series of commands that controls whether the router forwards or drops packets based on the information that are found in the packet header. So we'll see we'll inspect the packet header. After inspecting the packet header, we will either forward it or drop it based on these commands, the access control list commands. They are not by default configured. In general, they are used for the controlling traffic flow. Simple. So either it could be a security, so it could be filtering, it could be screening, but in short, in general, their purpose is traffic control. Okay. For example, you can see that here on the router 1, we're going to deny videos coming from this network. And also, we are going to deny an access from this switch to this area. So we cannot have an access from this PC2 to this network, and so on. So we will, all of the issues can be, for example, here we can deny FTP websites updates can be denied. So all these are mechanisms to prevent or control the traffic flow. So usually they are implemented using transport layer, network layer. So they are working at layer 3 and layer 4. So it's based on layer 3 and layer 4. So packet filtering usually incoming and outgoing. But this is a very critical. The first one, they are sequential. This sequential list of permit and deny statements, they are called what? Access control list entries. So we call them the access control list entries. And access control list entries are sometimes called what? An access control list statement. So access control list entries and access control list statements, there can be, we can have the same mechanism. So whenever a packet passes through the router, it will compare what? In sequential manner, step by step, to determine if the packet matches one of the access control list entries. So if it matches, the packet will be allowed to go. But don't forget this one. The last statement of the access control list is always an implicit deny. Always. Whether you write it or not, the last statement of an access control list is always an implicit deny. Don't forget that. That means whether you permit something or to somebody, but the last statement, even if you don't write it, the last statement is always what? Denial statement. So make sure that you always permit some of the statements, because by default, the router at the end of your statement, without knowing it, will write what kind of statement? An implicit deny statement. For example, if you permit let us take, if you permit for example for this network, if you permit for this network something, then if you implement it, if there is other network from this area, if you have a switch here, if there are, so if you deny it at this point, for if you permit something for this network, even if you don't deny it for this one, by default the system will deny it. So you need to make sure that you should know that there is an implicit deny statement always. So you can see that there can be two types of access or control list operations. We call them what? And also packets which are from the router itself will not be inspected. So this is one on another. So inbound means coming to some interface, and outbound means going out of the access control. So for example, here this is an inbound coming to the router, and you can see that checking out while going outside. So that's what we call it an outbound access control list. So if you implement it at the outbound, that's going to be inspected when the packet filters go out from this interface. When you inspect it at this area, so you are inspecting an incoming and an outgoing packets. So if you inspect an incoming packets at this area, you are going to inspect that. So there are two types of extended access control lists. One of them we call them standard, based on the source address only. Another one is an extended access control list packet. So in the case of access control list, in the case of standard, only you can see this is based on only an IP address. But in the case of here, you can see on the first one, on the protocol type, and also you'll see on the source and destination IP addresses, you can see the source and the destination IP address here. Any means all of the any recipient, and also you can see the port. So these are an extended control list. So both of them have their purpose is filtering, but one have a very broad controlling mechanism than the other. So you can see that the extended have a very that the name itself is an extended filtering mechanism. So the other types of standard and extended access control list, which both of them will use is numbering and naming. So if you don't want to forget, naming is a preferred one, but you can assign a number one. So numbering and naming, both of them can be used, but make sure that if you want to use a standard one, you are going to use these numbers from 1 up to 100 and from 1300 up to 2000. And the same for extended one, you can use this number, but whenever you use, you make sure that you use capital letters for the naming purpose. So we have discussed about, and here one of the big statement is that whenever you configure or filter based on extended access control list, you need to configure it as much as possible to the source. For example, if you are going to, we will come with that. So here, in the case of extended, it denies what? Denies undesirable traffic closer to the source without affecting the network structure. And the standard one, it's as much as possible to the destination. What about extended? As much as possible to the source. So now you can see that, so if you have, for example, if you are going to prevent some kind of transmission from this one to this one, so which one is the source? This one is the source. Which one is the destination? This one is the destination. So where do you prevent? So you want to prevent traffics which are going from this source reaching to the destination. So as much as possible, since we are going to implement it nearer to the destination, we are going to implement it at here, at this interface on the router, on this interface, without affecting this interface. So this is the standard one. In the case of extended, now assume that you are going to send a message from this one to this one based on the provided IP address. You can see that we're going from here to here. So from here to here means this is the source, this is the destination. So that's from the source to the destination. So from the source to the destination, you are going to implement it in such mechanisms. So so we say that this is the source and this is the destination based on the description that we have been provided. Where do we implement it? As much as possible nearer to the source, because we are implementing what kind of implementation? Extended access control list. Previously it was the standard one, now it is an extended access control list. So as much as possible we're going to implement it here. So which one is where do we implement access control list? Always they are implemented on the routers. So in this case, which way the packet is going to go from here to here? So through this interface. So we are going to implement it here at this interface. What interface? Gigabit 0 interface. So you can see we're going to implement it at gigabit 01. Previously, where did we configure? Previously, we were configuring it on the destination. So the destination was here, so we were going to implement it on this one. That was the standard approach. But in the case of extended one, you are going to implement it nearer to the source. So this is the source, this is the destination. So you need to differentiate between where you are going to implement it based on these two. So here, what did we here implement here? Extended, because this is the destination. Where did we implement it? The standard one. So we said that previously access control list has what? Entries. What are these entries? They are statements, access control list statements. And we will use, so what did they have? Always the permit and deny. So an access control list can be configured based on protocol, based on the protocol. You can see that here you have IPv4, that's the protocol, per direction. So you can see that an inbound, so this is an inbound, and this one is an outbound. So inbound and an outbound, so incoming or an outgoing. Here also we can implement it in every interface, and also based on the interface. So when we say interface, you do know that there are different types of interfaces: serial interface, gigabit interface. So here you can, based on interface, gigabit. So we can configure an access control list based on what? Based on protocol, direction, and so on. And extended access control list, we have said previously, extended access control list works based on what? Based on extended criteria. One of them is port numbers, TCP port number. So you can see that here you have TCP port number. For example, you have port number 18. Port number 18 is for HTTP, and port number 22 is for SSS. 21 is for FTP. So you need to remember these numbers so that you can implement them well. Now let us discuss about the wildcards. Wildcards are what? Mechanisms for filtering from the given IP addresses those that have been permitted. Now we can see that zeros means what? Zeros means exact match. Zeros means what? Exact match. Ones means what? Ignore. So when we have zero, zero means match. When you have one, ignore. So what you can see here, based on this one, you can, this is an IP address. This is your wildcard mask. How do you filter them based on this one? You can see, you can, whenever you have zero, what did we say? Whenever you have zero, that they should be matched. So when you match the upper one with this number, you'll get this number itself. But when you have one, what does it say? When you have one, what does it say? Ignore. So if you have one, you'll ignore it. You will put it, you'll put 0, 0, 0, 0, that number, ignore. Because even if you have here one, here you have one, so these numbers will be what? Ignored. That's the meaning of the wildcard mask. So whenever you have 0, what? 0 means matching. Whenever you have 1 means, that means. So if you have here these numbers, what does this means? Match all address bits because they are 0. What does this means? Match how many bits? The 2 bits, and the last 6 bits will be ignored. What about this one? Ignore the 4, match the 4 bits and ignore 4. So and so on. So now let us have this number. So what does this means? This means what? Exact match. Because all of them are 0, when you combine the values, exact match should be obtained. So when you combine these two numbers, you will get this one because you need an exact match. So this means that if you configure with this IP address and with this mask, only this host IP address will be permitted to use the network. What about here? Here it means what? All of them are 1. So 1 means what? Ignore all. So what is the result of this one? The result of this one means what? The result of this means all users will be permitted, all IP addresses. So the first one is exactly match. This is for this one, for the first one, exactly match. On the second one, on this one, anything. That one is exact. This one is anything. What about the third? The third is when you combine these two, these three zeros represent what? An exact match. So these three numbers should be repeated, 192, 168, 1. But the last, because the last number is ignored, so this one will be ignored. So the last will be 0 because the last bit. So who is going to be matched? Any IP address having 192.168.1 will be permitted, but the last number can be ignored. It can be 1, it can be 10, it can be 100, it can be 254, and so on. So in general, these IP addresses will be permitted, all. So 192.168, all of IPs will be permitted. So just wildcard mask calculation can be obtained if you are given this number. For example, you have been given this number. So from this, you can calculate what? The wildcard number. So the wildcard number for this one, just subtract 255 from each number. It's just like on OSPF, EIGRP, whenever you configure them, you're using the net mask, subnet mask. So you'll use this number, so you need to remember this one. So what is the meaning of this one? The meaning of this one is all three will be matched, and also in general 15 hosts will be permitted. 250 hosts will be permitted. Here almost we can say 255, and also this almost we can say 512 hosts will be permitted from this one, because we are in the next. So in general, this is but there are some abbreviations that we are going to use. Abbreviations: host means exact match, or it's the same as 000. Any means ignore all, that means 255, 55, 55. So we need to use these numbers whenever we use an equivalence. For example, here you have this number. This is an example. So you have this number with the mask 000. So we say that 000 means what? Exact match. So we can write it in this format. We can say host. If you say host and we provided an IP address, that means exact. If you say any means, for example, if you say any, ignores all the bits. So that's, you should differentiate between these two. For example, here you can take, this is what? Permit this 000 and 255. 255 means any. 255 means any. So here we can configure it in this format, or we can configure it in this format, or we can configure it in this format. So 000, because it doesn't make if you give it an IP or something. In general, any means all the users can use it. That's the meaning of the user. Usually we put it at the end, and you can see here it means exact match. So only this IP address is able to use the resources that are in the network. So this means what? That this can be configured to a host. Rather than writing all these zeros, you can just say host. So you can see that this is an OR statement. You can use the upper, this one, or this one, or. So from now on, I think probably we're going to use the host and the any command repeatedly, so don't forget that one. So we have said so most of the time when you configure access control list, they are configured in the firewall routers, which are positioned between the internal network and the external network. So usually that's most of the configuration that we are working are usually configured at the border gateway routers. So you can specify. So usually at the edge of your network, we'll configure on the border routers. So border routers, which are an interface between the outside world and the inside world. So what are the best practices of an access control list? So whenever you create an access control list, you should base on the policy of the your organization, prepare what the description, what you want to do, and we can use it. The text editor can be used, or in general, all this can be. So access control list. So we have previously said this. Where do we configure access extended account? We configure it possible to the source. Standard, if possible, configure to the destination. So for example, let us say, I think we have discussed this one. So access control list, we have discussed about. So how do you create an access control list? If you want to create an access control list, you can use this command. You'll say access list, then you'll say access number. So access list, we said that access standard will use from 1 up to 99, or previously we said they can also use between numbers that are around 1,000 to up to 1,200 numbers that they can use. So here access control list, you can just first, what is the first thing you do? The first thing you do is you will create the access control list command. Then what do you do? Then after that, you link it to an interface. So the second step is link it to an interface. So this is creating the access control list. So you can see access list 1. So the statement is permit. Who is permitted? This network, and with this net mask. Then you are going to do what? You are going to link it with an interface. Then we'll say an interface serial something. Then we'll say IP what? Access group 1 out. So what is the access group? So this is an access group. Who is going to use this number? 1. So who is 1? The 1 is this one, this number that we have created. So what is the purpose of 1? What kind of control is this? An outbounding. So you should remember these 3 commands. One is an IP access group. The first one is access list, and the second one, then you are going to configure it access control list. So if you want to remove, you'll say no. Then with no access list 1. Then you are after that you can write access list 1, and you can, it's just like editing. So we're editing using other configurations. So here what do? We are denying a specific host and permitting a specific subnet. I think you do differentiate between subnet and host. When you deny a specific host, that is a single number. So single host can be used using host command. And when you deny a subnet, you are going to use the mask. So for example, here we are denying who? 192.168.10.10. So who is being denied? So access list 1 is denying who? Host 1. So this host is being denied. This host is being denied. And what the second statement is doing? It is permitting this net, the subnet. So this is a subnet. This is a host. So the host is a part of a subnet. So when you say a subnet, all the members of this network will be what? Permitted, but this PC is denied. So then you are going to do what? You are going to configure it. Is it when the packet is outgoing, or where are we going to filter it when it's coming? So we are going to filter it when it is going out. That's outbound. So here you have an outbound. We said what? An IP. So this is linking the access control list with an interface. So it's going to be implemented on interface serial 000. So we're going to implement it on this interface. So what is the purpose of this interface? Whenever some information is trying to access from this PC to outside, it will be prevented. But other users on this switch will be permitted. So this will be prevented, then the rest can go out. So that's called an outgoing bound. So we have already previously done denying specific host. In this case, we are denying a specific host and we are saying what? Any. What is the meaning of any? Any user will be permitted. So the problem with the previous one, was what? We permitted for 192.168.10.0 network. But what about 11? So what did we say previously? Don't forget. Previously we said what? The last statement is always an omitted denial. So because only we permitted the use for this one, not only we prevented this PC, we also prevented the entire subnet from this network. So you need to be very, very specific when you implement the rule. So don't forget that one. So for example, here you can see what? We are denying this host. This has been denied. What about now? Now everybody is permitted. Everybody means not this network, but the entire except this PC. Except this PC, all the networks, when they are outgoing. So the previous statement should have been implemented here. You see, because previously we implemented here, this will affect this network also. So if we implement it here, if you implement it at this location, at this area, this network, the 11 network will not be affected because it can safely go out without being filtered. But the previous one was the... Now let us go to the naming type. Now you can see that we can see what? IP access list, then we'll say standard because there is no numbering now, then we'll provide it the name. No access. Who is going to be prevented? Only 1110. Now this PC has been denied and everybody has been permitted, but we are going to implement it. So it's just like this network is trying to access a resource which is coming to this one. That's what it should be. So that's the denial of the statement because we are implementing it at this interface. So at that interface, we are going to deny from this host, from this PC, but we are permitting everybody to come except this PC. And you can see that IP access group, previously it was a number, here it was a number, there is an in statement. Now you are using what? You are using name. So we are combining the name and other issues. We can also use text editor. So text editors can be used for configuring and writing it can be used for different mechanisms. So we can use numbering. So we can use, you can see that show access list number 1. So here you have access list 1. We have a number which is 10. So we might have a modification. How do we verify? Verification of access control list, we can use verifying or show IP interface. So show IP interface, in that case, show access list can be used, and you can also use we can see based on the interface. So you can see this is an access control list number and what kind of permission and denial have been created. So sometimes we can secure what? VTY line. So VTY line can also be configured to be prevented. So now let us discuss about the extended one. So previously we said that Extended is the number between what and what? Between 100 and 199, 2000 and up to 2000, almost around these numbers. So with the total of this one, so they can also be number, they can also be, now you can see that here you have what? An access list. So the number is 114 because it's an extended one. We said that it's greater than 100, and it is permitting a TCP, a protocol, TCP protocol, permitting who? Permitting for 192.168.20.0, and with the mask of this one, so all IPs starting from 192.168. So from this one, 192.168. 20 will be what? Will be permitted. The rest can be any number. For example, it can be 64 up to 255. So the last number is, so because what does it say? It says exact match for the first three numbers, and I ignore the last one. So you can see here you have 23. 23 is what? Telnet. You have F21, that's FTP, and you have, so you can use either the number or you can use the name of a well-known port. So you do know what the meaning of well-known ports. So equivalent, equal to, so eq means equal to, it can be sometimes QT, greater than or less than something. How do we configure it? We configure it through just like the previous one. So whenever you have this statement, established statement, now, for example, you can see this one. What is the purpose of this one? 103. 103 permits only what? What kind of requests? Port 80 and port 400. So this is HTTP and HTTPS. Both the web accesses have been permitted, and other things are what? Denied. And access control list. This also established statement. What is the meaning of established statement? Established statement means what? A response. It is related with the response. A response to the traffic that originates from this one mallet name. So that's the meaning of. So if it is a response for a request that have been previously requested by this IP address, that can return. So the meaning of this one means any reply which has been requested by this IP can come back. That's the meaning of established. Because we don't say this one, this number, HTTP, Telnet, FTP, established. So for example, we can say that if some PC from here requests something, that can be replied with the established statement. So we said previously what? Extended should be implemented nearer to the source. For example, but we don't see here. So here we have the service provider. So what does the first one do? It is doing HTTP, here HTTPS. For whom? Because we are implementing it at the source. So any HTTP request from this one, HTTP request from this area will be permitted. So when they are going out, they'll be permitted, and also established. Established means only for the requests that have been previously requested can come back. So that's both an outgoing and incoming. So in the case of, we're going to implement it on the gigabit serial 00. So in the case of Giga, the first two statements require the first two statements are outbound. The established one can use the in. So an access control list can be configured using equivalent of FTP data. We said that now, for example, in this example, what do we do? Where FTP traffic from subnet 192.168 going to, so is denied. So what it all other traffics have been uh, permitted. So from who to who? From this one, so this is the source. From who to the destination, this one have been what? Denied. All other traffics has been what? Permitted. So you can see that which one is the source IP. So this is the source, and the source of this one. So this is the source. Going to who? To the destination. So the destination is this one. What kind of request? The FTP request and the FTTP request. Both of them have been what? Have been denied. And also the last is what? Permitted. So IP from any source to any destination have been what? Have been permitted. So also we can use what? The same IP access list. Now we can say extended and the name. So in this case it's surfing, and also you can hear what? Browsing. So here you have the surfing. So the surfing is what? Requesting to an outside world. And so in the case of surfing is implemented whenever some information is coming. So and browsing on the outbounding. So browsing is on outbounding and surfing is on inbounding. So in general, we can use, so access control list can be we can do an access control list. We can do what? We can, for example, now we're in the case of troubleshooting. What's the purpose of troubleshooting? There is some problem on the network, but by looking at the configuration, we can identify where the problem exists. So now let us take this one. Now, here you can see that this is what? What is the problem here? So here you can see this is only one single statement. What is the problem with that? The problem with this statement, you are permitting only for 192.168.10.0. What about 11? You are permitting only for, we said previously what? Previously, there is always a deny statement after any permit statement. So if you are permitting only this network, what about 11? You should have specifically, these two, they are almost the same. Because in the first case you didn't write it, but the system by itself will write it. So these two they are the same. So access list 2 deny any. These two statements, they are almost the same. So even if you didn't write it in the first place, this network will be prevented by itself. What about here? Here you can see the problem here is the order of the sequence of the statement. First, you have denied 192.168.10.0 network, then you permitted a specific host from that network. It's not possible. Usually, a permit statement, if they are in the same, that's what we call it a conflict of statement. The permit statement should come first, and then you should go with the denial statement after that. So that's what you do here with this statement. So always the permit statement should come first, then the denial statement. You cannot, after denying, you cannot permit it. After permitting, then you can deny it. So you should be careful whenever you have a sequence. So here it's the conflict of statements. So here also you have another problem in access control list. So sometimes the most common errors is what? The wrong order. And the second one is not specifying adequate access control list rules. And the third is wrong direction, wrong interface, wrong source address. So For example, here you can see that PC2 cannot be able to access the file server. So here you have the file server. PC2 cannot PC2 cannot what? PC2 cannot access the file server that's here. But here the intention was what? The intention was so the intention, the output of here you can see what? Deny. Who is being denied? 1110. So 1110 has been denied. Well, sorry, I think I have wrongly interpreted. In our case, we just wanted PC1 from accessing the server, but sorry, PC2 should not be able to this PC should not be able to access this one. That was our intention. But because of this statement, you can see that the statement is what? It says deny 192.168.11.0. So that is correct, but we are denying every other users from that network because we didn't specify. You need to have this permit any statement. If you don't specify permit any, always deny everybody, every user. So that you should be careful. So this statement should have been included in this statement. So this should have been included here. That's why we have this kind of problem. So this, in order for this PC to have access to this resource, you should specifically specify permit any statement so that other users will be able to use that one.